In this video, we want to continue on and discuss indefinite integrals. And this is very much related to the antiderivatives. And in fact, they are the same thing. The collection of all antiderivatives of f is called the indefinite integral of f with respect to x, and is denoted by, and here is our symbol, it is the indefinite integral, or the integral sign, of f of x dx. This dx helps tell us that we are doing the antiderivative, or the integral, with respect to x. And that is our definition of the indefinite integral. The symbol, this symbol here, is an integral sign. And the function f is the integrand of the integral and x is the variable of integration. All right. Let's go ahead and do a couple of examples real quick on calculating indefinite integrals. Let's evaluate. And A here is going to be evaluate the integral of x squared minus 2x plus 3 dx. All right, just like in derivatives, when we take the derivative of multiple functions or multiple terms here, we just take the derivative of each term respectively. Well, we're going to do that here when we take the antiderivative as well. So really, this is the antiderivative of each of these terms respectively. So, what is the antiderivative of x squared? Well, the antiderivative is, we follow our rule. We add 1 to the exponent, and then we divide by that new exponent. So this is 1/3 x cubed. Minus, all right, this will be x squared, but then we divide by 2. 2 divided by 2 is just 1, so we just get negative x squared there. And then the antiderivative of a constant is just the constant times the variable of integration, so 3x. And then at the end, we add some constant c for our general antiderivative, or our indefinite integral. Now, if we had really taken the antiderivative of each of these separately, we would have gotten a constant at each of those points, but then all three of those constants added together is a new constant. So we don't generally write that down. We just write down a plus some constant at the end instead of writing down 3 individual constants. All right, so let's go ahead and find the antiderivative of, now we're going to do something a little bit different, cosine of 3x minus sine of 2x dx. Now this is a little bit different, and later on we're going to learn something called u substitution that will help us integrate this whenever we have a function inside of a function. But we don't have that yet. So we're going to cheat a little bit just by recognizing that when we take a derivative of something like this, we end up multiplying by the inside function. So if we're going to go backwards, we're going to divide by that derivative of the inside function. And in fact, earlier I should have said multiply by the derivative of the inside function. So here when we go backwards, we're going to divide by the derivative of that inside function. And that's essentially what is happening here. But we should just recognize then that the derivative of sine is cosine, so the antiderivative of cosine is sine. So the antiderivative of cosine of 3x is 1/3 sine of 3x. And the derivative of cosine is negative sine, so the antiderivative of negative sine is cosine. So this is going to be plus 1/2 cosine of 2x. And then, of course, we need to add some constant c here. Now, just to verify this, you should go through and derive this and make sure we get back to cosine 3x minus sine of 2x. Right? If we take the derivative of sine of 3x, that is 3 times cosine of 3x. And then that 3 times the 1/3 cancel. So we just get left with cosine of 3x. If we take the derivative of cosine of 2x, that is negative 2 sine of 2x. So negative 2 times the 1/2 just becomes a negative 1. And so we do, in fact, get negative 1 sine of 2x. And the derivative of c is 0. So once we take the derivative of this, we get back to here, which tells us we were correct in our antiderivative calculation. All right. And that is it for our discussion on indefinite integrals.